Morning, I'm Rory and welcome back to Sawyer Academy. In this video, we're going to take a step back from talking about sawing theory and we're going to talk about head saw alignment, how the physical head saw is aligned with the carriage. A little backstory, about a year and a half, for about a month, all of my double cut bandsaws started to crack. Now there's a handful of reasons why a head saw will crack, and we kind of went through each of those and ruled out issues in the saw filing room, issues with feed speed and lubrication. And what we ended up landing on is that the head saw itself was not only out of alignment with itself, but out of alignment with the saw line and how the carriage was running down the tracks. So what we ended up doing is contacting the former head millwright of Davidson Sawmill, who's retired, who came in and helped us, as well as the former head saw filer at Davidson Sawmill, who's currently my saw filer. And the three of us went at trying to find out what the issue with the alignment of my head saw. So I'm by no means a millwright. Take this all with a grain of salt. This is what we did and this is how we did it, and it worked. Like I said, this happened about a year and a half ago, and for the last year and a half it's been 100% no cracks. I'm making this video for two reasons. The first reason is for myself to reference in a few years that if I have to do this after I can't call anybody else in and I'm left on my own, or I'm working with people who don't have that same level of experience in the future, I'll be able to reference this video of how we did it and what we did, kind of thing. As well as if there's anybody out there who's running into the issue of your head saws cracking and you don't know what to do. Most sawmills with head saws of this size usually have a very developed maintenance personnel and equipment and training and experience. So this video might not be useful to you at all, but if there's sawmills out there with head saws this size, double cut, band mills, and you're running into the issues of your head saws cracking and you've checked what you think you could check in your knowledge base, maybe this video helps you. Head saws, even once they're set up, so my head saw, like I said, been working fine for the last year. They're physically bolted down, like they can't really move, but over time, bolts come loose, things move around, bearings get more play. So it's good to check. I'll be checking my head saw's alignment every year. When, like, during summer shutdown, I'll be checking it every year, so I can reference this video. You can reference this video, and I'm just going to talk through the steps of what we did. And to start, there's going to be three main steps. Step one is align bottom wheel with the track. Step two is going to align top wheel with bottom wheel. And step three is going to be align saw guides. So let's break down each of these steps individually and we'll start there. So step one is going to be aligning the bottom wheel with your tracks. Now the carriage tracks have two different types. The frontmost track is just going to be a flat track. This is like looking down the length of the track. It's just a flat track that kind of sets the height of the carriage, but it doesn't reference where the carriage is. The track furthest from the head saw will be more of a hexagon shape, and that actually indexes on the wheels. The carriage wheels will sit in that hexagon shape, and that references front to back where the carriage is. Now your tracks, when they're installed, are usually welded to a superstructure of the building, and they have adjustment in them, but they really shouldn't move. So the first step should be to make sure your tracks haven't moved or haven't broken free or bolts haven't come loose, or if you're just installing new tracks, make sure they're straight, make sure they're level. Everything is going to be based off the tracks. With what we did, we never adjusted the tracks. The tracks had been installed a few years before that. We didn't make any adjustments height-wise or alignment-wise of the tracks. The tracks stayed in place. All of the adjustments we're talking about today is adjusting the head saw to the tracks. So to understand that, the carriage itself and the saw line and the plane, the two-dimensional plane that everything happens in is referenced off of this backmost horizontal track. So if you look at a top-down view, you can imagine this being our bottom wheel of the head saw, which is about a 6-foot diameter wheel. If you can imagine, the wheel of the head saw has adjustment in it to turn, referencing these tracks. So how do we figure out, is that bottom wheel in alignment with not this front track, but with this backmost track that we're indexing off of? There's two ways we did it. The first way, we used a piano wire, and the second way we used a laser line. Both had advantages and disadvantages. That's why we use both, to get a more consistent reading. To use the piano wire, what we did is, to keep the wheel from turning, we jammed the wheel. I think we wrapped a bunch of chain around it, chain and block and tackle, and we locked the wheel in place so the wheel wouldn't spin. We wrapped piano wire around the back side of the wheel, ran it off the front, and crossed that backmost track. Now this piano wire was touching at the back side of the wheel, and it was just that it was touching the front side of the wheel, so that you're just running a straight edge along the side of the wheel. If you had a theoretical 20-foot perfectly straight piece of metal, you could use that. The problem is, off the front side of this bottom wheel, you're very limited in your space of what you can get out, because there's usually like the chassis of the head saw, for lack of a better term, in front of that. So we had to drill holes. We drilled about a 1-inch hole or a 2-inch hole to be able to run the piano wire out of, and then to shine the laser line back into. So you're very limited on how your access to this bottom wheel, but whatever you have as an option, you want to be able to run perfectly alongside the bottom wheel, and ideally closer, if we look at this again, closer to the middle of the wheel. The closer you are to the middle, the more accurate it's going to be. We were probably in the top third, just based on where that hole was that we had to come out of. So ideally closer to the center. You're going to have your 2 points of contact, 1 and 2. They're going to be further apart the more in the center your wheel are, and the more accurate you're going to be. Like I said, we were probably in the top third of the wheel, which still worked. So now we have this perfectly straight reference line coming off the wheel out into here. Next step is we use blue Dykem dye to spray on both tracks. And what we did is we sprayed this area here with dye, we sprayed this area with dye, and then about 5 feet away, let's say 5 feet and 5 feet, we sprayed that as well. So what does that give us? We're making a triangle, and then we're going to reference that triangle to tell us if we're in line, or how far off of alignment we are. So with that, I'm going to draw a new diagram. We have a line coming off the head saw. We have a line. This line is now going to be 10 feet long because we got 5 feet and 5 feet. And then we have this and this, which is going to be these two measurements. Where this line, whether it's a piano wire or a laser line, where it crosses these two tracks, we're going to make a dot. A very specific dot, both in the middle, right in the middle of the tracks, where that line crosses both tracks. And then with a center punch a very, very small hole in the tracks, and that's going to be our reference point and what we're going to measure off of. Then off of this dot on this back track, We're going to measure off 5 feet, and we're going to measure off 5 feet, and we're going to make another dot in the tracks. And those are going to be all our points in relative space as far as what we're going to be measuring from. Whatever you use to measure, it doesn't really matter if it's tape measure or if you have a straight edge to measure. We use tape measures, but we held off a few inches. Don't use the very end of the tape measure. Hold off 1 inch or 2 inch, and then use the same, both the same side of the measuring tape, and hold the measuring tape the same way every time. What we're looking for is these diagonal lines. Well, let's call that A, and we'll call that B. The length, the hypotenuse, the lengths of A and B have to be exact. If they're not exact, then you know your head saw is not out of alignment, or it's very slightly misaligned. So to use my real world example of what we did, we used the piano wire, and then we went back and again, we did the laser line 2 ways. From those measurements with the die, with the punch marks, measuring tape, this is actually what we got. So we had 60 inches. That's just what the millwright recommended we use. We have our line coming off the wheel, and from that we can draw a triangle back to that front track off the bottom track. Again, punch marks in the center of the tracks. Find our hypotenuse of our triangle for this line. This line measured 80 inches and 9/16, and this line measured 80 inches and 15/16. Now, if those numbers were exactly the same, then you'd know this line was perpendicular to your back track, and your head saw is squared to your tracks. Ours is slightly off. So if you work this out for your X and your Y, you're at 90.27 degrees and 89.73 degrees. So you're very, very close to 90 degrees, but you're off by 0.27 degrees, which is enough to cause the head saw to crack. So now we know that our bottom wheel is out of alignment with our track. The bottom wheel has jack bolts and lockdown bolts that allows you to twist the wheel back and forth as much as you want. So now we know how much it's out, or we know that it's out, and we know which way to turn it based on which way your line is, right? But now is kind of how do you figure out how much to turn the wheel? And this is the tricky part. The easiest way might be just to brute force it and to turn it a little bit and then recheck it and turn a little bit and recheck it. The problem with the rechecking part is that it's very tedious and very finicky. To be able to move that piano wire or laser line 30 thou, 10 thou, a little bit. We were using jack bolts on a jig that we welded to the floor to be able to slide the piano wire back and forth. So we had like some fine-tune adjustment, but it wasn't very easy. So the way I went about it, and what seemed to work fairly accurately, is to then break down this triangle. Real world measurements we took, into something a little bit more manageable. So my bottom wheel is 72 inches, 6 feet. Half of that, half the diameter is 36 inches because my jack bolts were located right on the center shaft of the wheel. So if I turned the wheel one way, the front of the wheel, the front of the wheel not only turned out, but the back side of the wheel turned in. So whatever adjustment I did was basically doubled. Right? Because I'm not moving just the front or just the back. I'm moving the front and the back at the same time. So that's why I'm going to take the measurements I got off the tracks, use that Y measurement of 89.73. The opposite angle is 27. My angle side B, let's call it, is going to be 36, which is half the diameter of my wheel because my jack bolts are in the center. That's going to give me the short measurement of 170 thousandths of an inch. And from that, I'm going to divide that by 2 because I don't want to move the whole length because my front's going to move, my back's going to move. I only need half of that. So half of that is going to give me 85 thousandths of an inch. So is it accurate? Is it theoretical? It worked for us because it gave us a point in space to move to. And what we did with that then is we used a dial indicator with a magnetic base, locked that onto the chassis of the head saw, and put the dial of the indicator right on the very leading edge of that bottom wheel, zeroed it out, and then with the jack bolts, we unloosened the bottom wheel, turned the bottom wheel in the direction we wanted to go with the jack bolts until the dial indicator showed us that we moved that 85 thousandths of an inch. At the wheel, it was 85 thousandths of an inch, and at this other end of the track, which was about six feet away, I believe off the top of my head, it was about 7/16 of an inch that line turned, that 0.27 degrees we tried to turn. Did that, rechecked it, we were good. So that's kind of the two methods I would say to go about. Once you know it is out of alignment, how much and which way to go is math it out. It's trigonometry, it's kind of complicated, fairly straightforward if you know what you're doing. The other option is you know which way the wheel has to turn, you're not sure how much to turn it, just turn a little bit, turn a 30 thou, recheck it, turn another 30 thou, recheck it. Those are going to be, I think, your two main options. I just like to quantify with a dial indicator how much are we turning and make sure you're turning it the right way. Once you recheck it, you're trying to get to where your X and your Y in this example is going to be 90 degrees, as close to 90 degrees as reasonably possible, and that these two measurements here are going to be as close as possible, if not exactly the same. So our second step in this process is going to be to align the top wheel with the bottom wheel. The bottom wheel now is set to where we want it. We have it locked down. It's not moving anymore. Our next adjustment is going to be, well, to check and then probably to adjust the top wheel so that it too is in line with the bottom wheel and thus in line with the track. So the way you can picture it, top wheel, bottom wheel. Our bottom wheel is locked into place. Our top wheel is going to be above it. Now our top wheel could be canted either side. We want to be able to check and then bring that into alignment wherever it is in space with the bottom wheel. How do we do that? The way we did that is we have a special jig that we made in-house. I'll throw a picture up of it right now. And what we can do with that is clamp it to the top wheel and basically have a plumb line coming off the front side, and then later on we're going to move to the back side, and we're going to check how these apexes of the wheels are in line with each other using physical measurements. So the way you can imagine that is off the top wheel, this jig that we're using is going to get clamped to this top wheel. It has a little arm off the side of it, and off that arm is going to have a plumb bob that's going to come down and hang next to the bottom wheel. Now there's lots of ways to keep the plumb bob from swaying around. Little can of oil, some sawdust in the hand, whatever you got to work with. And what we're going to do, while somebody's holding the top wheel from spinning, somebody's holding the plumb bob from plumb bobbing around, somebody's going to check on the bottom wheel what this measurement is here. Let's call that X. And then off the top wheel, we're going to call that Y, because we want X and Y to be exactly the same. So what we can do is check that on, let's call the front side, and then we're going to roll the wheels backwards. We'll leave that clamp to the top wheel, as well on this bottom wheel, on this front leading edge, where we're going to measure off of. We're going to make a little dot, paint marker or Sharpie or something, and then we're going to roll the top wheel back 180 degrees to the back side. As well, we're going to roll the bottom wheel 180 degrees, and we're going to measure off the same point off the side of the bottom wheel. And that's to eliminate, the faces of the wheels are machined, the sides are not machined, they're cast iron wheels usually. So to eliminate inconsistencies in the wheel itself, on the bottom wheel, you're going to measure off the front side, you're going to roll it to the back, and you're going to measure off the exact same point on the bottom wheel. Your top wheel, you're clamped to it, so that's not going to move. You got to make sure your clamps are tight and the jig's not flopping around. You're going to roll the wheels to the back, and then you're going to recheck this measurement. And what that'll tell you is if you're in line. If those numbers are the same, you're in line, and if they're not, you're gonna be able to know which way the top wheel has to turn. And again, that top wheel is gonna have jack bolts at the center axle, and you're gonna be able to turn that top wheel. You're gonna be able to turn that top wheel back into alignment with the bottom wheel, just based off of rolling the saw to the back, or rolling the top wheel to the back, checking your measurements. You can use your jack bolts, turn that top wheel, bring that jig back around to the front, check your measurements again, roll to the back, check your measurements again, and just keep rolling this top wheel from the back to the front with somebody down in the basement using a measuring tape, measuring off this bottom wheel, the space between the wheel and the string, whatever it may be, 8 inches, 2 inches, whatever it is, and just going back and forth, front to back, until those measurements are all the same. The third and final step of finishing the alignment of the head saw is going to be to set the alignment of your saw guides and any deflectors there are. I'm going to use mine. I'm not too well versed in all the setups that are out there, but I'm sure every head saw is slightly different. The way I set up mine is my bottom wheel is slightly larger than my top wheel by design. I use a 3/8 key stock to push the blade 3/8 off the top wheel, and I get a perfectly plumb head saw. Head saws normally aren't perfectly plumb above the top guide. They kind of cant back to add tension, and then your cutting area of the head saw, let's call it, is perfectly plumb, referencing the carriage head blocks. So the top and bottom wheel are now set. This is going to be our bottom wheel. We're going to, in my case, top guides, lower inside guides, lower outside guides, and then we're going to have a sawdust deflector right above the bottom wheel to keep sawdust from getting between the blade and the wheel. If you get sawdust packed in between the blade and the wheel, that's going to also cause cracking. So now that our head saw, the blade itself is in alignment, we're gonna have to go back and check all of these. So our top guide, again, has jack bolts we're gonna set. In my case, it's gonna be 3/8 tension. Our bottom guides don't actually touch the saw during normal operations. They're set to, I'll call it 30 thou, maybe it's slightly less. I use a piece of paper, folded in half, 2 pieces of paper, that's my shim that I should be able to get into here. Those just hold the saw from deflecting too much. So I'm going to set my bottom inside, bottom outside to that 2 pieces of paper. And then my lower saw guide, which is a piece of Teflon. It's also, people call it the brass because it used to be made of brass. Now I find it's more often made of Teflon. You're going to set your brass again to that 2 sheets of paper clearance. That some sawdust is going to get in there, but if your saw is rubbing on the Teflon, even though it's Teflon, it's still going to create heat, and heat's going to be bad for your saw. So you want to make sure that only your top guide, unless you have a 2 guide setup. A saw I previously used to use had a top and bottom guide that both ran against the wheel. So every setup is going to be slightly different. Just make sure that when your guide is intentionally touching the saw, it's set to that correct tension, in my case 3/8. And the guides that don't touch the saw, usually, especially your lower outside, I don't believe ever should touch the blade, and it should be set to that, I call it 2 pieces of paper. And then your lower brass, your sawdust deflector, set to two thicknesses of paper. But that's going to do it for today. Thanks for watching, and I'll see you next time.